All right, so today we're going to be looking at measures of center and measures of spread. So measures of center is kind of like the middle of the data, right? That's what center means. So for the center, measures of center, for today's objective, I can determine the mean and the median. So mean and the median are measures of center. And then we have measures of spread. So measures of spread is how spread out the data is, or how consistent your data is. So we're looking at the range and the IQR for the measures of center. And interquartile range, another word for interquartile range is the IQR. For its abbreviation, IQR stands for interquartile range. Okay. All right, so for our prior knowledge here, it says we have Caleb and Kim have bowled 3 games. Their scores are shown in the chart below. So they have 3 games, and then we're supposed to find Caleb's average score and Kim's average score and enter them in the table. So for the average, do you guys remember how to calculate average? Good. So you take the sum of all your values and divide by the number of values. So add all the values together and then divide by how many numbers you have on the list. So if we look at Caleb, I'm going to put C for Caleb. I'm going to add 151 plus 153 plus 146. And we're going to divide by how many numbers we have. So they had played a total of 3 games, so you divide by 3. And that'll give you the average for Caleb. So please grab your calculator. I'm going to add those 3 numbers together and then divide by 3. Okay, so lefties, if you're sitting on the left side, go ahead and tell your partner what you get for the average for Caleb. Okay, so I heard some of you guys say 150. Did you guys all get 150? Yes? Okay. Now we're going to do the same for Kim. So Kim now, we're going to add her scores and divide by 3 because she also played 3 games. So 122 plus 139 plus 189. And she played 3 games, so divide by 3. Okay. So on your calculator, add the 3 numbers and divide by 3. And righties, if you're sitting on the right side, tell your partner what did you get for your average for Kim. I didn't hear you guys talking. Am I going too fast for you guys? Make sure you guys are plugging it in the calculator. All right, on a count of 3, you're going to tell me what did you get for the average in 3, 2, 1. 150. Okay, thank you. This is also 150 for Kim. So what do you guys notice from their average? How do their average compare? They're the same, right? So we're going to say, bless you, their averages are the same. Their average score are the same. Okay? But if we look at their individual data, it says whose scores are more consistent, Caleb's or Kim's? Looking at the average and comparing it to their scores, which are more consistent? More consistent, like they're about the same every time. If we look at Caleb's 151, 153, 146, those are all pretty close to 150, right? But if we look at Kim's, That's 122, 139, 189. None of those are even in the 50s range, right? The 150s. So whose is more consistent? Caleb is more consistent, right? They're all like roughly in the 150s. Kim's it averages out to 150 because she has a very small value and a very large value. 122 and 189. Those are pretty far apart. It's like over 60 points apart from each other versus Caleb's. It's only from 146 to 143 is the range. Those are closer. That's less than 10. So Caleb's scores are more consistent. And then if we look at how far or close they are to the mean or to the average, looking at these are pretty close to 150. These are not very close to 150. So is Caleb's scores farther from the mean or closer to the mean than Kim's scores are? They're closer, right? Caleb's scores are closer to the average than Kim's scores. So we'll kind of see why that happens today, and then which data would be more appropriate to describe. That's just prior knowledge right there. So for today's concept, we're going to learn about measures of center. And again, it's the mean and the median are measures of center because they represent the center or typical value of a data set. So how do we find the mean and the median? The mean we just saw for prior knowledge. You take the sum of the data set divided by the number of values in the set. And then for the median, it's just the middle value, but specifically you need to arrange them in numerical order to find the middle value, okay? So if we look at an example, we have here the number of text messages that Isaac received in each day for a week is shown. And you're supposed to find the mean and median number of text messages per day. So the very first thing you want to do is put them in order from least to greatest. So if I were to reorder these numbers, I have my smallest value is what on the set? 47. So I write it down. But I also have another one over here. So I'm going to write 47 2 times. And then my next smallest is 48. Then we have 49. Then we have 50. Then we have 54 and 55. So double check, you have 1, 2, 3, 4, 5, 6, 7. And we did have 1, 2, 3, 4, 5, 6, 7. I recommend to just double count because sometimes you might miss one accidentally. But we do have all 7 values. Alright, so for the mean, we've already kind of seen how to do this for prior knowledge. To calculate the mean, you want to add all of those together. And then you're going to divide by how many numbers you have. We have a total of 7 numbers. So can you guys go add for me 47 plus 47 plus 48 plus 49 plus 50 plus 54 plus 55. And tell me what you get when you add all those together. 450? You guys all get 450? Yes? Okay. And then divide by 7 for me. 350? Okay. Okay, thank you. All right. And then divide by 7 for me, and what do you get? 50? Okay. So the mean is 50, and then to calculate the median is the middle value. So since we have 7, the middle number on the list would actually be the 4th number, right? Because if you have 3 on each side. So then if I cut the data in half, for example, I have 47 here, 55 here, 47 here, 54 here. I'm going to go from the edges until I get to the middle, okay? And then a 48 and a 50 kind of cross out, and then we're left with 49 right in the middle. So I have 3 on each side of the 49. So that tells me that 49 is actually my median. Median is 49 because it's the middle number on the list, okay? And you want to put it in context since we have kind of like a context attached to the set of values. So you want to say the mean is 50 text messages per day. So Isaac receives an average of 50 text messages per day. And then the median is 49 text messages per day. All right, and then if you look at the data, both of the 49 and the 50, those are roughly the same, right? 49 and 50, they're approximately the same values. So it doesn't matter if you use the mean or the median in this case to describe the center of the data because they're both pretty much the same, okay? Sometimes you might have different values like 150 for the mean and you'll have like 100 for the median. Those are very different. So then you want to figure out which one would be more appropriate to use. In this case, they're both about the same. So it doesn't matter if you use the mean or the median. But if we look at this example, it says we have the amount of money Elise earned in tips per day for 6 days is listed below. And then we're supposed to find the mean and the median tip dollars per day. And then we have a follow-up question, which we'll get to that in a second. But let's go find the mean and the median. So remember, you want to put these in order from least to greatest. So what's my smallest value that we have? 75. And then it's 84, 97, 100, then 119, and 360. Okay. All right. So if you notice, this time I have 6 values. Because I have 6, you end up with an even number on each side with nothing really in the middle, right? So like, for example, what I mean is if I go cross out from the outside to the inside, 75 with 360, 84 and 119, and then 97 and 100, and you have nothing in the middle, right? So again, I end up with like these 3 on this side, and then these 3 on this side, with nothing in the middle. I do not have a specific value here in the middle, right? So when that happens, you need to take the average of the 2 middle values, okay? So I'm going to take the 2 middle values and then I'm going to find the average between those 2, okay? So what's 100 plus 97? We get 197. Divide by 2, and that's going to give us our median value. 98.5. And then if you think about the context, this is talking about money, right? So the 0.5 is really going to represent $98.50. Okay? Again, I can hear people asking, why did we divide by 2? Why did we take the average? Just to clarify, because I know some people might have the same question. They're just embarrassed, I guess, to ask. But why did we end up having to take the average of these two?
There's 2 numbers.
There's 2 numbers. We don't have an exact number right in the middle, right? If we don't have a number right in the middle, you have to take the average of the 2 middle numbers, okay? And then that was the median, yes?
So if there's 3 numbers in the middle,
If there's 3 numbers, then you're really only going to have 1 in the middle. Okay. Then let's talk about the mean. So again, the average, you're going to go add all 6 values together. And we're going to divide by 6. $835. Can you guys verify? Add all 6 numbers together? Yes? Okay. And then if we divide by 6? 6, so this will actually be 17 cents, right? Because we're talking about money, you want to do the hundredths place. So 139 and 17 cents. Roughly. Okay. So again, in context, we would say the mean is 139 and 17 cents in tips per day. And then the median is $98.50 in tips per day. But do you notice, are these roughly the same? Those 2 values? They are very different, right? If we look back to this one, we had 50 and 49. Those are pretty similar. So we could use either. It doesn't matter if I use the mean or the median. But in this case, I have 98 and 139. So which one is a better representation of the center of the data? If we look at the mean, where would the mean be located on the list? 139.17 would land somewhere right here, right? The mean ends up being larger than all of these data except for one. The mean ends up being larger than all of these except for the 360. So the mean in this case is not a very good representation of the center because I don't really have anything, well, I shouldn't say anything, but notice the mean does not end up in the center. So you do not want to use the mean in this case because the mean ends up being larger than all of them but the 360, okay? So this 360 is probably an outlier, and so we'll learn about outliers in our next lesson, I believe. So my question here is, which measure of center, the mean or the median, is more accurate in describing the typical value in a data set? And so which one is more in the center? That's actually median, not the mean, because the mean ends up being larger than most of the data except for one. Okay, so in this case, we would say the median is more accurate because the mean is larger than all but one data value. So it's not very accurate because it's much larger than most of the data, okay? And then we could say the mean the median is more in the center. So we would want to use the median because it's in the center of the data. Because as a measure of center, the median ends up being in the middle versus the mean is not in the center. It ends up being pulled towards the right. So measures of spread, again, is how consistent your data is, how spread apart your data are. So we have two different ones that we're going to focus on today is the range and the interquartile range. So those are measures of spread, and they're used to describe the consistency of data values or how far apart the data is from each other, okay? And then it says, how can we find the range in the interquartile range? So the range is the difference between the largest and smallest data values. So for the range, that's when you take the max minus the min. Take the largest value and subtract it from subtract the smallest value. Then we have this interquartile range, or the IQR, is the difference between the third quartile and the first quartile. So for the IQR, you're going to take Q3 minus Q1 for the IQR. So the IQR represents the range of the middle half of the data when the data is in order. So main thing is it has to be in order from least to greatest. And then we have here the first quartile is Q1, is the median of the lower half. Then we have the second quartile, Q2, is the same as the median. And then the third quartile, Q3, is the median of the upper half. Okay? And I know that probably doesn't make any sense right now, but I'm going to show you just a quick example. You don't have to write this down if you don't want to, but like, let's say I have a 2, 2, 3, 4, 5, 6, 6 is my data. So to find Q1, it's going to be the number on the middle. So 4 would be my Q2, which is the same thing as the median. We don't really ever use Q2, it's the median. And then that cuts your data in half. So then you have the lower half here. So then Q1 ends up being the middle of the lower half. And then you have the upper half over here. So the middle of the upper half, that 6 right there, would be my Q3. That's what Q1, Q2, and Q3, that's how you get them. It's the median is Q2 right in the middle. It cuts your data in the lower half and the upper half. So then lower half is Q1, and the median of the upper half is our Q3. Okay? So that's essentially what we're going to be doing today. And then for the IQR, you would then just take Q3 minus the Q1. So if we look at our first example here, it says we have the April high temperatures for 5 years in Boston area are shown. We're supposed to find the range and interquartile range for the temperatures this time. I'm not sure if you need to copy any of the values. Is it all there for you guys? Yes? Okay. So 77 degrees Fahrenheit, 86 degrees Fahrenheit, 84, and so forth. So just like we did before, we want to first put them in order from least to greatest. So my smallest value that we have is 77. Then we have 84. Then 86. And then we have 90. and 93. Okay. For the range is pretty quick. The range is just max minus min. So what's my biggest value that we have in the data? 93. Minus the smallest value is 77. So what's my range? 16. Shh. My range is 16 in this case. You just take the max minus the min. Then to find IQR, you need to do Q3 minus Q1. So IQR, we need Q3 minus Q1. So I need to figure out what are Q3 and Q1. But in order to do that, I need to know what's the median. And so I have a total of how many values? 5. So if I cut it in half, I have these two are in the lower half, and then these two over here are my upper half. I'm cutting the data in half, and then notice I end up with 86 right in the middle. So 86 ends up being the median. Median is 86. Right in the middle is 86. And then I need to take the middle of the lower half. But notice, I don't really have a middle value. I have 2. So, Nick, what do we do when we have 2 of them?
Divide.
By what?
2.
Okay, but we have to add them first and then divide, right? So what is 77 plus 84?
It's 161.
161. Divide by 2? What is that?
80.5.
Thank you. 80.5. So that's going to be our Q1 is 80.5. And then I have my upper half over here. Again, I don't have an exact middle value, so then I'm going to have to take the average again. So we're going to do 90 plus 93, which is going to give you what? 183? And then divide by 2? 91.5. Thank you. So that is going to be our Q3 because it's the middle of the upper half. So then now I can calculate the IQR. I'm going to take 91.5 minus my 80.5. And that'll give us the IQR. I heard somebody say 11. Okay. And then don't forget you have to write it in context. So we would say the range is 16 degrees Fahrenheit. And the interquartile range, or you can just write the IQR, is 11 degrees Fahrenheit. Yes. No, in the directions say we're only finding the range and the IQR. All right, let's look at another example together. So looking at this one, I'm not sure if you need to copy any of the values down. But my context here says we have the number of runs scored by a sophomore team in 10 games are given. Directions again are find range and the IQR of the runs scored. So my data, we have 3, 4, 8, 12, 7, 5, 10, 12, 3, and 9. But we want to put them in order from least to greatest. So least to greatest, go ahead and take maybe like 10 seconds or so. Put them in order from least to greatest. Oh man, I forgot the 3. I mean the 4. So I skipped the 4 and 2 3s in the front.
Yeah.
All right, you guys have them in order?
Yeah.
Okay.
Yeah.
Double check. I double check them because I skipped the 4 accidentally. I had to go back to it. Okay. We have 3, 3, 4, 5, 7, 8, 9, 10, 12, 12. So for the range, remember we're doing max minus min? Whoosh. Max minus min gives us 12 minus 3, which is what? 9. Okay. And then to find the IQR, we're going to need Q3 minus Q1. So let's go find first the median. We have how many data sets? Total, it should be 10, right? Do I have 10 values? 7, 8, 9, 10. Yes. So because we have 10, if I cut it in half, what's half of 10?
5.
5. That means I have 5 on each side. I don't have something right in the middle. So I have 1, 2, 3, 4, 5 for the lower half. And then I have 1, 2, 3, 4, 5 for the upper half. So this is my lower half. And this is my upper half. I don't have something right in the middle. So what are we supposed to do to find the median? Add 7 and 8, which is 15. Divide by 2 gives us 7.5 for the median. All right, then for the lower half, I have 5 values. Do I have something in the middle this time? Right in the middle?
No, you just no.
Yes, we have 5 numbers.
Oh, 4.
So 4 is right in the middle. So Q1 is 4. Q3, I have 5 numbers again, so right in the middle is 10. So to find the IQR, we're going to do 10 minus 4, and that gives us IQR is what? 6. And then don't forget to put it in context. We would say the range is 9 runs, and the IQR is 6 runs. Okay?